the moment formula, the R cross product with the F, is it? Okay. So this moment is about the whole system. We consider the moment for the whole system. However, this is what we want to know about an axis. This moment is about for the I, J, and K axis. Okay. So now we want to focus the moment for n axis. So in order to know the moment about either I axis, either J axis or K axis, so we just modify the formula become mx equal to ma equal to ua multiply with the r cross product with the f. So from this one become this one. So it means that we just add the formula, this thing. So by adding this one, so automatically you can know the moment about n axis. Okay. It looks like difficult. You see the formula. Easy. The formula is it? It looks like. Okay. So if you convert to the mathematical equation, if you still remember that, this is moment formula I, J, K. This is Rx, Ry, Rz. This is Fx, Fy, and Fz. Okay. So this is for this moment. However, for this moment, okay, for this moment it will become, you will have I, J, K, same thing. And then you have Rx, Ry, and Rz. You will have Fx, Fy, and Fz. However, you will add another one, which is Ux, Uy, Uz. Find the moment about x axis. Example, the question is find the moment about x axis. So it means that here you need to find the mx, because x axis a become x equal to ux r cross product with f. If you convert to this formula, this is because x axis, you need to find the ux. So ux will become 1 because you want to find the x axis. So that's why ux become 1. The rest become 0 and 0. That's all. Okay. So this is the mathematical equation if you want the question find the moment about x axis. So the ux become 1, the rest become 0. So let's say if I have another question, find the moment about z axis. This one will become 0, this one 0, this one 1. Like that. Okay. So it means that the value here at the first row, it depending on the question. If the question asks about z axis, then become 0, 0, 1. If x axis become 1, 0, 0. If y axis 0, 1, 0. Okay. The Rx and Fx, everything here is similar with the previous class lecture. How you to find it? Same thing, similar. Okay. So now you know the concept. Now we do the example lah. So in this case, your UA will become, because of x axis, UA will become 100, is it? So I can say that 1i plus 0j plus 0k. Because of x axis. Okay. And then after that, you need to find the R. You need to find the R. The R from this is, let's say, O, and this, let's say, this is B. Okay? The R from O to B, ROB. So firstly, we need to draw the path. The path actually from O it go up and then travel at this distance and go up again, is it? This is from O to B. Okay. Firstly, it travel about the Z axis, yeah? Z axis. Is it have any X axis direction? So it means that the R here, it did not involve any X direction, is it? Yes. So the R here, the X direction will become 0i. Okay? And after it go up, do you know the distance? Not yet. Do you know the distance between here and here? No, you don't know the distance, is it? And then after that, it travel from here to this point at the Y axis. How many? 0.3 JK. J, because at the Y axis, is it? And then after it go up again at the Z axis. So it means that the summation of the Z axis here plus with here equal to 0.25 K. Which is in meter, is it? So it means that it travel from 0 about this one, travel here and here. So this is the distance ROB. Okay. And then after that, we need to find the F. F here, this is magnitude of vector. 200 this, magnitude or vector form? Magnitude, is it? Because this is just value 200 Newton. However, if you want to use the moment, we need to convert in the vector form. So that's why this force we need to convert to the vector form. So you can see that this is the force and this is Y axis, is it? How many angle between the force and Y axis? 60. How many angle from the force to the Z axis? How many angle for force for the X axis? 120. So it means that in order to find the Fx, we need to know the angle between the force and X axis. So it means that the force, since the angle force and X axis is 120 degree, so we use cos 120. Why? Why I say that? If you still remember this triangle force, let's say force, yeah? And then this is Fx and this is Fy. Let's say this is your angle, is it? So whenever you want to find the force which near to the angle, just beside the angle, you use cos or sine. So whatever when you find, so you can F cos theta. So it means that whenever you want to find the force at the axis beside the angle, you use cos. If you want to find the force opposite the angle, you use sine. Sine theta, eh? So now, this is your force, this is your angle, this is the force that you're looking for, which is Fx, is it? Is it the angle is beside or opposite? Beside the angle, is it? So that's why you use cos here. Okay? So now, this is for the Fx plus Fy. This is the Fy. The angle opposite or beside? You use cos or sine? So you use 200 cos 60 j direction. Okay? And then this is your Fz, is it? The angle opposite or beside? You use cos or sine? Okay, so plus with 200 cos 45 at j direction. So that's why you use cos, you don't use sine. If you want to find any opposite, then you use sine. Beside, you use cos. So 200 cos 120, I believe. So you just put all the information in this table I, J, K. I, J, K. Your UA is 100. Your RA is 0, 0.3 and 0.25. Your F is negative 100, 100 and 141.4. Okay. And then what? And then if you still remember last week, I asked you to add another column. Copy again 0, negative 100, is it? Copy again, eh? If you close the eye, then you will have this thing, is it? Okay. So the mx is about 0.3, 1, 2, 3, 4, which is 1 multiplied with 2 minus 3 multiplied with the 4, which is 0.3 multiply 141.4 minus 0.25 multiply with the 100. What is the final answer? 17, 14. 17.3. 14. This one. Okay. Okay, so let's say I give you given a moment 20 Newton meter clockwise. So if you want to translate this statement to numbers, what is the value of the moment actually? Given a moment 20 Newton meter clockwise. This is a sentence, is it? If you convert to mathematics, it will become negative 20 Newton meter. Okay, is it clear? Because the word of clockwise, it represents negative. If the word is counterclockwise, it represents positive. Okay. Just remember this hand gesture. You know that this is counterclockwise, this is positive. Okay. This is your reference. Okay. So this is our last example for the moment about an x-axis. So you look at, find the moment of F about the hinge axis Y. So you look at this one, automatically you look at these keywords. Moment axis leakage. Is it leak, water drop?
Yes, some way. Mostly.
Okay. So you want to change your?
It's okay.
It's okay. Okay. So now, because we want to find moment axis Y, so the formula become moment of Y, U, Y, R, cross product with the F. Okay, automatically, yeah. So now we'll try to list out all the information that we need to find. So the UY will become 0I plus, what was it? 1J plus 0K. Okay? Kan? Because the keyword there, moment axis Y. So we need to find the moment about Y axis. So UI are cross product with the F. So you need to find the UI, you need to find the R, you need to find the F. Okay, the vector. So the vector for the UI is 0I plus 1J plus 0K because moment of Y axis. Okay. And then after that, we need to find the R. The R. So, there are so many numbers there, is it? You have 0.6, we have another 0.6, you have 1.2, you have 1.2. So, which R that you need to look? Do you know that? Which one? Huh? AB. AB, are you sure AB? Are you sure AB? Okay, let's see. If we go back for the previous class, yeah? Do you still remember the hammer thing? Hammer example, kan? Hammer example, group exercise. Group exercise, yeah? You still remember this one, kan? Okay. If you still remember, the R that you need to find for this moment is from here to this one, go up to this one, is it? Is it correct? Still remember? So it means that the R must always from 0, origin. Okay? Origin until the starting of the force. So this is your force starting point, is it? Your force starting point is here. So the R must measure from origin to the starting point of the force. That's your R. So in this case, this is your origin. So it means that the R to calculate the moment is from 0 to A or B? To A. Because A is the starting point for the force. So it means that the R here, you need to calculate R O A. So it's not RAB, no. It's not ROB because here we can have, from this figure we can have three informations R. We can have three informations of R from there. ROA, ROB, and RAB. But we need to use the correct R. Okay? If you want to calculate the moment, the R must always from origin to the starting point of the force. That's your R for the moment. Okay, so that's why in this case, we use RO. ROA lah. Okay. So the ROA in this case, I just the ROA pass is from O to A only, is it? From O to A. So what is your ROA vector? I am wrongly 1.2 1.2 positive or negative? Okay, this is your ROA. That's all. Kan? Okay, now we already have our U information, we have already R information. Now we want to find the information of the F. Remember, if you know how to solve it, I mean you already understand what we discussed from week number 1 until today. If you know how to solve this thing. Okay? And then for the F. So now F there, 120 Newton in scalar or in vector? In scalar form, in vector form? Scalar form, 120 Newton. Okay? So now we want to convert the scalar to vector. Fx, Fy, and Fz. For the first example, given the angle kan, you just use 200 cos 45, so easy yeah. However, in this case, is there any angle given? So you need to use the position vector formula, which is F multiplied with the vector unit. Vector unit. What is the symbol for the vector unit? U. U. U is vector unit. The vector unit here is, the formula is F multiplied with the R divided by magnitude of R. If you still remember, the vector of R divided by the magnitude of R. So now, once again, we have three R here. You have ROA, ROB, RAB. Which R that you need to use? RAB, because the vector there is from A to B. Okay? The vector is from A to B. The force is from A to B. So that's why in order to convert this force to force vector, you must use the R between A, B. Okay. So you cannot use ROB because this is the direction for the ROB. I think I punya lukisan is not okay kot. Boleh lah. Okay. Okay, so this is for the ROB from 0 to this one, to this one, to this one. Is it related to this vector? No, is it? The direction for the ROA here. Is it related to this force? No. So that's why we need to use the RAB in order to convert the force from scalar to the vector. So now, how we want to find RAB? I give you the equation. Is it make sense to ROA plus with ROA plus RAB, you get ROB. Is it correct? Then, so ROA plus RAB, you get ROB. Or you can simply AA cancel, then you get OB. So that's why ROA plus RAB, you get ROB. So now, in order to get RAB, you need to find ROB minus okay. So now ROB, this is the path. ROB, O to B. This is the path from the O to B. This one, and go up. ROA, this is the path. So, we try to find ROB first. From O to B, firstly, it travel at the y-axis, is it? How long the distance? 0.6 ij, okay? J. And then it travel another 0.6. Which direction? Positive, negative? Then you get. Okay. And then it travel up. What is the distance? 1.2. Positive, negative? 1.2 K. Okay. And then for the ROA, once again, 1.2 I. That's all, is it? 1.2 I. So it means that the RAB, which is ROA, ROB minus ROA equal to 0.6 I plus 0.6 J plus 1.2 K, and then divide by 1.2 I. Finally, you get negative 0.6 I plus 0.6 J plus 1.2 K. So this is your RAB. RAB. Already know this information. Then we need to find the magnitude for the RAB. And then this one will give you what is the answer? 1.47. Alright. So now at the end, you know that this force you can convert to vector. The F equal to 120 multiplied with the your RAB here is negative 0.6 I plus 0.6 J plus 1.2 K divided by 1.47. And then you do everything, do all the maths and everything. Finally, you get negative, negative 49. Negative 49 I plus 49 J plus 98 K Newton. Close the Y. When we close the Y, this part give you the square, is it? This one is it give you a square? So that's why we need to solve this part lah. So it means that 0 multiplied with the negative 49 minus 1.2 multiplied with the 98. You get, what's the answer? 1.2 and 98? 117 point. Positive, negative kan? Negative. The answer is, so the moment there, the answer is negative 117.6 Newton meter. Yes. Okay, for the couple moment, the R that we use here is the R between the two forces. Okay, I explain to you. Let's say you drive a car. You drive a car. This is, what is it? Steering. Do you H type or Honda type? Kelisa. Dia Pro 2. Logo Pro 2 apa? P. P. Pro 2. Okay. Is it P? Is it? Where's the logo?
It's like
Oh, like that. I don't know. Okay. So this is steering wheel. Imagine your hands, one grab here. This is your hand. Okay. And then you want to turn left. You want to turn left for sure. Okay, that's the logo. Tengok, once again. Okay lah. Okay. So it means that for sure, if you want to turn left, so it means that one force go up and one force go down. So this is what is the meaning of the couple moment. Is it symmetry? Is it in a pair? However, but in different direction. So let's say this is F. This one should be minus F. This is the meaning of the couple moment. Okay. So, in order to solve the moment for the couple moment, the R here actually is the distance between this is your R. Okay. So it means that if you want to find the moment at the first one, the R always from O to the starting point of the F. If you want to find the moment about N axis, the R always refer to the from origin to the starting point of the F. However, for the couple moment, you need to use the R between the two forces. That's your R. Is it clear? Okay. Open the resultant moment. Then automatically you must know this is the formula that you need to use, which is okay, R multiply cross product with the F automatically. Okay, so now once again we list out the all information that we need to use. The firstly we need to find what is our R. Since this is the couple moment, so we need to find the R between the two forces. So it means that this is our first force and this is our second force. So what is the R between these two forces from A to B? Okay, from A to B. Firstly, it travel how much? 0.9 at X or Y direction. Firstly, it travel here. And then it travel down, is it? So firstly, it travel 0.9 at the X direction I or J plus V, and then it go down how much? 0.3, is it? I or J? Positive, negative? Negative. So plus with negative 0.3 J direction, which is 0.9 I minus 0.3 J. That's all. Okay. And then after that, so it means that this is our starting point from A, our end point at B. So now we need to consider the force at the end point, which is at B. So the force at the B, because we already find our R, so now we want to find the information of the F. Information of the F. So the F we need to find the information is about B, not A. Why B? Because our distance from A to B. So it means that we need to refer the force at the final point, which is at B. At the B, our force at the X direction, what is the value? 2 kilonewton, is it? At the X direction. This should be in meter. 2 kilonewton at the right, positive I, and then at the Y direction, what is the value? Negative F. So negative F at the J direction. So the unit is kilo Newton. Okay, because our F here already separate into X and Y. Don't confuse us because already in X and Y axis, yeah. So you just use the information only. Okay, so this is our F. 2I minus Fj kilonewton. Okay, our question is we need to find the F value. Okay, so now we convert this information to the table. Okay, and then after that we just and 2, and then we just settle one by one because this is not about and exist, so we need to settle everything lah. If about and exist, we just choose one column only, but this is not about and exist, so we need to calculate the moment for the whole system. Okay, so we close I, 0.3 minus multiply 0 minus 0 become 0 I. And then we close the J, this one multiply with 0 multiply with 2 minus 0.9 multiply 0, you got 0 plus 0J. And then plus we close the K, then we get 0.9 multiply with the negative F minus 0.3 multiply with the 2, then we get negative 0.9F minus 0.6, is it?
Yes.
It's supposed, this one minus should be positive lah. Okay, minus with negative 0.3 multiplied with 2, so become no. So this is our moment lah. However, the question give you the moment is 1.5 kilonewton meter clockwise. So clockwise positive, negative? Negative. So it means that this value actually equal to negative 1.5 kilonewton meter, which is this is also kilonewton meter, and then you set everything. So negative 1.5, we just remove the kilonewton meter, we remove the kilonewton meter, so we just take the value only. Negative 1.5 equal to negative 0.9F plus 0.6, and then we set everything. What is the value final? Negative 2.1 equal to negative 0.9F, F equal to negative 2.1 divided by negative 0.9, actually equal to 2.33 Newton or kilonewton? Kilonewton. So this is answer.